Good evening. Welcome to AP Chemistry. We are going to be talking about reaction rates and kinetics. This is where we left off in class the last time we did lecture. I left you off with this graph here, and it shows the balanced chemical equation at the very top, right there, as having 2 moles of NO2 breaks down to form 2 moles of NO and 1 mole of oxygen. So we can see the graph that the reactants decrease over time, and that is this green line here. We see the decrease right there. Reactants decrease because as the reactants disappear, technically they don't really disappear, but as the reactants disappear, products are being formed. So if you can see here, there's my products of NO and my product here in red of O2. So what you notice is that the O2 and the NO do not form at the same concentration. If you look back up on at the coefficients, you have twice as much NO gas forming as O2. So what that tells us that reaction rates are not constant. The speed of the reactants will change over time. What we're going to do is we're going to calculate the instantaneous rate, and that can be calculated by using the slope of the line tangent to the curve at a particular time. So that's going to be calculated as rise over run. The reaction rate expression in units would be moles per liter times second. So in order to calculate instantaneous reaction rates, if we want to pick a moment in time, and we draw a little dot, and sorry, this dot isn't drawn as perfectly. So again, instantaneous reactions are going to be something where, sorry about that, I'm having some technical difficulties. So we're just trying to talk about instantaneous reaction times. And we know that so far, if we pick a moment in the time, say where this dot is right here, and I know it should be perfectly on this green line, but it's not, so let me say it's right there. What we can do is if we can find the slope that's tangent to this line, and we can calculate rise over run, we can calculate out the instantaneous reaction. So you're just going to calculate rise over run. Now the change in the reaction is the rate of the rate will change depending on the change in the concentration. So when we're looking at reaction rates, we always notice that the reaction rates for reactants are always negative. Well, why do you think so? Give you a little moment to think. And the reason is because reactants disappear. So since they disappear, we calculate them as negatives, and while products appear. So if products are appearing, their reaction rate will be positive. So the appearance of the products compared to will be compared to the disappearance of the reactants. So as the reactant concentration declines, the product concentration increases, and that's going to be consistent with the stoichiometric values, and we're talking about the coefficients of the balanced equation. So if we look at this equation, 2NO2 forms 1 mole of oxygen plus 2 moles of NO. What they're saying is the rate of the disappearance of NO2 is equal to the rate of appearance of NO, yet it's twice as fast as the production of O2. And so what they're saying is 2 moles, and another way to say it is 2 moles of O2 disappear for every 1 mole of O2 form. So therefore, the rate at which O2 forms is going to be equal to half the rate at which NO2 disappears. So we can calculate the relative rates of reactions, and all you need to do is you just divide. First you find the rate of the concentration, so that's the change in concentration divided by the change in time. And to find the relative rate, all you do is divide by the coefficient of each reactant and product in the balanced equation. So therefore the radiative reaction for the equation up above is -1/2 change in concentration of NO2 divided by the change of time, and that would equal 1/2 the change in the concentration of NO over the change in time, and would also equal the change in concentration of O2 over the change in time. And what we do here is we're only going to look at 2 of these at any one particular time, and it's just a relative rate to compare one rate to another.